So today we're going to have our quarterly exam review. It's day 2 of the review, and we're going to be covering chapter 6 today. As a reminder, your quarterly dates are as follows: tomorrow, Tuesday, March 24th, and Wednesday, March 25th. The first thing we covered in chapter 6 was systems of linear equations. A linear equation is defined as two or more linear equations. How do you know if you have a linear equation? It's going to have the equal sign. Don't confuse this with the linear inequalities. Those have the inequality symbols, and we'll talk about them in a little while. A linear system of a linear equation, we're going to have an ordered pair. So we're going to be looking at any ordered pair that makes all of the equations in the system true is called the solution of the linear system. We're going to go over this in about a minute or two. So how many solutions would a system have? Well, we can have one solution, and in one solution, the lines will intersect somewhere. They are going to have different slopes. So in this example, we have y is equal to 2x plus 7, and y is equal to 4x minus 6. In the first equation, our slope is 2x, and in the second equation, our slope is 4x. As long as those two equations right there have different slopes, there is going to be one solution. We can also have indefinitely many solutions, or as we like to abbreviate it, IMS. The lines will be exactly the same. So we'd have something that's like y is equal to x plus 7 and y is equal to x plus 7. The slopes are the same because the number in front of x is 1, so we have 1x for the slope in both, and the y-intercepts are also positive 7 in both. So as long as the lines are exactly the same, we have infinitely many solutions. We can also have no solution. The lines would be parallel, and they would have the same slope, but a different y-intercept. So our example would be y is equal to 3x plus 6, and y is equal to 3x plus 15. Slopes are the same here because they're both 3x, but our y-intercepts are different. One of the equations, it's positive 6, and one of the equations, it's positive 15. So if I asked you guys how many solutions would a system have, you have three options. One solution, indefinitely many solutions, or IMS, and no solution. One solution, the key is the lines are going to have different slopes. So as long as the slopes are different, one solution. We can have indefinitely many solutions. Key thing here is the lines are exactly the same, and it could be no solution. So basically the same slope but different y-intercept. So the lines are going to be parallel. So we're going to solve a system now using substitution. Basically what we're going to do is we're going to solve the equation for one of the variables. So we're either going to get x or y by itself, and then we're going to substitute the expression for the variable into the other equation. We're going to break that down in a minute or two. So let's solve this system using substitution. So I want to know what the solution is. So I give you y is equal to 2x plus 7 and y is equal to x minus 1. Now both of these lines are both y equals lines. We don't have to do any rearranging. This top line right here, we have y is equal to 2x plus 7, and this bottom line, we have y is equal to x minus 1. Y's are both by itself, which is completely fine. So now what you're going to do is you're going to take one of these lines and plug it in for that variable. So what I like to do is, because I took this bottom line, so we have y is equal to x minus 1. Wherever there's a y in the other equation, I'm going to plug in x minus 1. So I went ahead and did that. So I got x minus 1 is equal to 2x plus 7. Now your next step is to get all your like terms on one side. So my first thing I like to move is I like to move the x's. So we have a positive x over here. So to get rid of it, we have to subtract each side by x, and we get negative 1 is equal to 2x minus x, so 2x minus 1x, we get 1x plus 7. Like terms are still not all on the same side, so we got to subtract each side by 7. And then we get x is equal to negative 8, because negative 1 minus 7, we get negative 8. Now I'm telling you guys to go ahead and use your calculators. You get the answers a little bit quicker, and you don't always forget about that negative sign. So once we get that x is equal to negative 8, we now have to go and find the y. So what you could do is you could plug this negative 8 into either equation. I chose to use the top equation. It's the first one I saw. So wherever there's an x, we're going to plug in negative 8. So we get y is equal to 2 times negative 8 plus 7. We go ahead and multiply 2 times negative 8, and we get y is equal to negative 16 plus 7. And then we go ahead and combine our like terms. Negative 16 plus 7 gives us negative 9. So y is equal to negative 9. So our solution to this system is x is equal to negative 8 and y is equal to negative 9. When you do these, you're always going to have two answers. So let's try this one. Would it solve the system using substitution? What's the solution? So we now have y is equal to 3y plus 4x is equal to 14, and negative 2x plus y is equal to negative 3. Ignore my 6 over here. We're going to use him in a little while. So what you have to do first is you have to get one of these equations to have either x by itself or y by itself. The first equation, there's a little more work involved because you're going to have to end up dividing by another number. We don't want to do all that extra work. So in the second equation, we have negative 2x plus y is equal to negative 3. So the y is all by itself. So let's move this negative 2x. Let's get y by itself. So to do that, we add 2x to both sides. When we do that, we get y is equal to 2x minus 3. So once we get there, now we can take this y is equal to 2x minus 3 and plug it in, not into the equation you just rearranged, into the other original equation. So wherever there's a y, we're going to put 2x minus 3. So we had 3y. So now it becomes 3 times, and all in parentheses, 2x minus 3, close your parenthesis, and just rewrite the rest of this equation. Plus 4x is equal to 14. Now we take this 3 and multiply it by the 2x, and then we take it and multiply it by the negative 3. So we get 6x minus 9 plus 4x is equal to 14. Now we could go ahead and combine like terms. So now we have a 6x and a 4x on the same side. You don't have to go ahead and do what we did up here, plus like how we did the plus 2x's. They're on the same side, so we literally just do it across how it is. So we get 10x minus 9 is equal to 14. Now we got to get this 10x by itself. How do we do that? We're going to add 9 to both sides, and we're left with 10x is equal to 23. Now we got to get x by itself, so we divide each side by 10, and our x is equal to 2.3. Remember, because we're finding the solution of the system, so we got to find x and y. Now you have to go back and plug in this, whatever you found for x, to find y. You could go ahead and use this top equation, but why would you want to do that? This bottom one, y is all by itself. It's easier to use this one. So what I go ahead and do is, wherever there's an x in this bottom equation, I'm going to plug in 2.3. So I get negative 2 times 2.3 is equal to negative 4.6 plus y is equal to negative 3. Now we got to get this y by itself. So we got to add 4.6 to both sides. And when we go ahead and do that, negative 3 plus 4.6 gives us 1.6. So your answers to this solution of the system is x is equal to 2.3 and y is equal to 1.6. Now we're going to solve systems using elimination. You are going to eliminate one variable. So basically what that means is you want one of the variables to be the opposite of each other. So you want one positive and one negative. What I mean by that is you want one y positive and one y negative, or one x positive and one x negative. So let's use elimination to find the solution of the system. I give you guys 5x minus 6y is equal to negative 32, and 3x plus 6y is equal to 48. So what I go ahead, now what I like to do is I like to rewrite the problem. So we have over here, we can't cancel out the x's because we have 5x and 3x. We can cancel out the y's because we have a negative 6y and a positive 6y. So the y variables cancel out, and now we just go ahead and add. 5x plus 3x gives us 8x, and negative 32 plus 48 gives us 16. So we have 8x is equal to 16. Now we got to get x by itself, so we divide each side by 8, and when we do that, we get x is equal to 2. Remember, because we're finding a solution of the system, we got to have both x and y. So now what you go ahead and do is you plug in to either of these equations. Wherever there's an x, you plug in 2. So what I like to do is I'm going to use the bottom one. So I do 3 times 2, we get 6. And then we just rewrite the equation, plus 6y is equal to 48. So we go ahead and do that again. I just rewrote it again. So we have 6 plus 6y is equal to 48. We subtract 6 on both sides. When we do that, we get 6y is equal to 42. Then we got to divide by 6 on both sides to get y by itself. And then we're left with y is equal to 7. So your answer to this solution is x is equal to 2 and y is equal to 7. Let's try this one. What's a little special about this one is neither of them are going to cancel out right away with itself, because we have a negative 5x and a 3x. Well, those x's aren't going anywhere. And then we have a negative 2y and a positive 6y. They're not going anywhere either. So what you have to do is you have to take one of these equations and multiply it. So I'm going to work with the top equation because I think it's a lot easier to get this 6y to cancel out than to get the 5x or the 3x, because in this, to get the 6 to cancel out, you would only have to multiply the top equation. You multiply that by a 3. So what we do is 3 times negative 5x, 3 times negative 2y, and 3 times 6. And when we do that, we get negative 15x minus 6y is equal to 18. Now we can take that equation, the one we've multiplied by, and add it to 3x plus 6y is equal to 6. So then you get over here negative 6y plus 6y. Those are going to cancel out, and then we just go ahead and add negative 15x plus 3x gives us negative 12x, and 18 plus 6 gives us 24. You got to get x by itself. So now what we do is divide each side by 12, or negative 12, and we get x is equal to negative 2. Because it's a solution of the system, we got to now plug in this x is equal to negative 2 back into one of these original equations to solve for y. So I plugged it into the bottom one because I don't want to have to worry about this negative 2y. So I plug in the -2 in for the wherever there's an x in that bottom equation. So I do 3 times -2 plus 6y is equal to 6. 3 times -2 gives us -6 plus 6y is equal to 6. We got to get that 6y by itself, so we have to add 6 to each side. And then when we do that, we get 6y is equal to 12. To get y by itself, you divide each side by 6. And then we're left with y is equal to 2. So your answer is x is equal to -2 and y is equal to +2. And linear inequalities. We'll have the inequality symbols less than, greater than, less than or equal to, and greater than or equal to. As a reminder, less than and greater than both have dotted lines, and less than or equal to and greater than or equal to both have solid lines. I'll ask you, is the ordered pair a solution? So I'm going to give you the inequality. Y is greater than x minus 3. I give you the ordered pair. 1, 2. Remember, it's always x, y. So what we go ahead and do is we plug in these numbers in for x and y. So I rewrite the equation. So then I go ahead and plug 2 is greater than 1 minus 3. And then when we simplify 1 minus 3, we get -2. And then we're left with 2 is greater than -2. Is 2 greater than -2? Yes. It's true, so it is a solution. Now I go ahead and give you -3, -7. Rewrite the problem, plug in for x and y, so we're left with -7 is greater than -3 minus 3. Simplify -3 minus 3, we get -6, and then we're left with -7 is greater than -6. -7 is not greater than -6. It's false, so it is not a solution. And graphing linear inequalities, that's the last topic. For the graphing linear inequalities portion of the quiz review, I'm going to link the video for the linear inequalities review I gave you guys last week when you had your linear inequalities quiz. I think watching that video again will be very helpful for you guys. So remember, your quarterly is tomorrow and Wednesday. If you guys have any questions, please make sure you email me ASAP. Good luck, guys.